Ladies and gentlemen, welcome at the Hanover Fair, here at the group exhibit Hydrogen Fuel Cell and Batteries. I'm proud to present you another stage, another fulfilled information evening going ahead right now. I see someone smiling. Do you like to have a coffee? There are young girls running around giving us some coffee, even a water they do. Yeah? If somebody else, maybe you or you, like to have something to drink and join us here on stage, take place. We got several seats just empty enough for you. So please help me welcome from the company Dexmet Corporation, directly from the USA, which I'm very proud of. It's also very international, Mr. Kenneth Burtt and John Hart, Vice President and Business Development in complete personality here. Thank you very much. A little bit louder. Oh, great. Please take a seat.
Thank you.
So directly from USA, or did you have some days here in Europe?
Pretty much came directly here from the USA, so we had to come in obviously and set up for the show. So it's good. We wish we could spend more time here in Germany. We do like coming over to this country.
Maybe we could force you the next time doing several things on stage so that you can stay longer here.
We do that, yes.
And you two, did you arrive very well? I saw you yesterday and 2 days before here.
Yes,
right?
actually, I came in with my wife, and we flew into Amsterdam, and then I came over by train. So I had one day to walk around there. She stayed there to go to museums, and I came over here.
So you gave up your wife in Amsterdam.
Yes.
You're free to work. I can make this kind of jokes because only one girl here. All the technician side is here to see what's about your company. That's why they're here. They're looking at you. Tell me a little bit about Dexmet, please.
Well, Dexmet is an expanding company. We do expanded metal foils and polymers. And for those of you not familiar with expanded metals or expanded polymers, it's a process in which we take a solid foil and we do a mechanical process on it and essentially create an open area product. So it's really a slit and push process that we do on the material to create the open area. So, we'll take that, we'll give a different dimensions on the tool, different feed rates we do in the machine to create anything from a certain conductivity you want in the material, or is it a certain flow rate you want in the material, or is it a certain surface area that you want in the material. We can kind of dial into characteristics to give you exactly what you need in either a metal or a polymer.
So this is a very decisive point, very decisive material in the photovoltaic industry, in the car industry, and in other industries too. But the fuel cells, belonging to the fuel cells, what kind of development did you do in this direction with your material?
Well, we've been working with the fuel cell industry for a very long time. We've probably worked on the electrolyzer side of supplying materials for over 50 years. And then on the actual PEM fuel cell itself, we've been supplying materials for close to 40 years. So we know a lot about electrolyzers and we know a lot about fuel cells and supplying materials into that industry. What's unique about our products is that they're not a woven product. They're a homogeneous piece of material, so they don't unravel. They have good conductivity, and they work really well in the applications inside of a fuel cell, whether it be an electrode, a catalyst substrate, a gas diffusion layer, maybe it's a membrane support. So there's a number of different applications within a fuel cell that a Dexmet material can be used for.
Good conductivity is also a very main point on that.
Yeah, it's what's nice about the geometrical structure of an expanded product is that you get very good airflow over it. So if you're trying to use it for a gas diffusion layer and you're trying to get good even airflow over your electrode or your catalyst, the tortuous path that the air goes through will actually distribute that airflow evenly over the catalyst. So it makes for a much more efficient chemical process. So.
Chemical process is also a nice overheader for just the next question. But Mr. Hart, I could bet you're the newbie in the company, right?
Yes, yes.
And I just want to know what kind of idea is behind that you started to work for this company right now.
Sure. Well, my background is I've been in the industry with fuel cells and lithium-ion batteries for the past 10 years. And I recently joined Dexmet about 2 months ago because although they've been working for a long period of time with fuel cells and electrolyzers and with primary batteries, we've recognized that we also wanted to be in the lithium-ion market. And to get into that market required a much thinner type of electrode material, current conductive material, that we could offer. And so for the past couple of years, Dexmet's been refining their tooling and machining processes so that we could provide the thickness of foil that's necessary for lithium-ion batteries. And so I was brought on to start identifying who the players are in the lithium-ion market, where they're located, and start reaching out to people to bring awareness to the fact that we now offer expanded materials for that market.
So how does this play into your cards?
Well, you know, it's opening up new marketplaces for us, and that's always from the sales and marketing standpoint. That's really the most interest for us. You know, we've played in the fuel cell marketplace for a long time. Like John had mentioned, we have done a number of years on the primary battery side, but never had the right materials to be able to get into the lithium iron phosphate marketplace. And it's really because we were kind of stringent on the technology of our expanding equipment. So over the years, we've evolved our expanding equipment to go to thinner and thinner materials. So now for the lithium-ion batteries, we're getting down to 25 micron thickness. We're trying to go below that, and we're getting down to the sizes of the hole size, or the opening size, down to 25 micron and below. So it really lends itself to the lithium-ion battery industry. And so it's going to open up a new marketplace for us, and that's why we brought on John to try to find that, you know, the companies that are working with that lithium-ion technology and find a way to be able to help them get into a design that will use our materials, because we know that there's a definite benefit to using open area products for either the anode or cathode on a battery.
So as I understand it, you got a lot of, so the way you're talking, there's a lot of experience behind the product. Can you go a little bit deeper in this kind of experience, or those many experience you have?
Well, we've been expanding material for over 60 years, so we have a lot of experience with a lot of different applications. You know, not only the fuel cell and, you know, battery, but, you know, we do a lot of work on the lightning strike for the aerospace industry, EMI, RFI shielding materials, and it's always constantly evolving into, you know, what is the next marketplace and material that we can open up to find a new utilization for our materials. And again, the lithium-ion battery marketplace is key for us, because we see such a huge growth in the battery marketplace, for especially here for energy storage. You know, we have windmills, we have solar panels. How do we collect that energy that's being produced? And, you know, some of it's going into an electrolyzer and making hydrogen gas for this. So we're touching many ways of energy and alternate energy fuel sources in the materials that we produce.
You brought some examples for your materials.
Yeah,
Yeah,
go ahead. We brought a few of the flow fields that we have, some of the titanium products that go into catalyst substrates.
Are these the titanium ones?
That's a particular, we have the nickel ones. So
Yeah.
nickel would be something that you find more on a solid oxide fuel cell side. And then the titaniums would be more on the PEM fuel side.
Am I allowed to show the audience what you brought?
Please,
here?
yeah. Yep.
Well, during this stage, it's a public forum. Public means you're the public, we are the forum. Yeah? You're allowed to ask questions all the time. Yeah? Just look at the materials we have here. Yeah? Just look at the materials we have here to show, or maybe there's a question about it. Are questions allowed?
Yeah. Absolutely.
So just have a fine look at the materials, and maybe you have a question then. Do you like to have one? You too? Okay. Maybe you asked your neighbor. And these are the special materials for the fuel cells.
Yeah. So there's titaniums and nickels with different aperture sizes. And really what we can do is, you know, there's an example of some of the patterns and characteristics that we can put into the material. But, you know, we can make changes according to whatever application-specific requirements that you need. So if you need more open area, or maybe you need a certain geometry or a certain flow rate across the material, we can tweak the characteristics to be able to produce exactly what you need on an expanding process.
That sounds very fine, but I need some more information about the step into the battery region. This is also material what kind of words do you have to those examples?
Yes, well, as we've been mentioning, is for fuel cells, there's a certain integrity of the material that is needed.
Yep.
For batteries, it requires much, much thinner material, and that's what we've been refining down to 25 micron. And where this is utilized is as the current conductor for both the anode and the cathode. Samples of our copper, 25 micron, which would be for the anode, and
Can I
aluminum.
handle them
Yes,
out?
please,
Yeah,
distribute.
okay.
And aluminum that would be used for the cathode. We recognize that, although the fuel cells and all these new technologies are coming along, in the near term, batteries are going to be extremely important. And that's why we've decided we really want to focus on developing the technology so that we can offer these products for the lithium-ion battery industry. We're working with a lot of institutions, a lot of small businesses and startups who are working on developing new types of materials, new chemistries for lithium-ion batteries, new such as silicon anode and graphene anode and all the different chemistries for cathode. And we don't do our own internal research. We rely on our customers to feedback to us what they're finding when they use our materials. And some of the feedback we're getting is in a recent early stage evaluation of our materials for an NCA, a nickel, cobalt, aluminum cathode material, our customer indicated that he was able to demonstrate a 17% increase in the milliamp hour per gram energy density on that cathode material. Because of the porosity of our material, when you spread that slurry, you not only get the layer that you get on a normal foil, but you also get it into those pockets of the porosity, which is where we enhance that capacity. So if you're looking at driving down the cost of a battery or increasing the energy density so you can either reduce the size of that battery or put more battery capacity into the same foot factor, this is where there's a great deal of benefit for that. We feel very strongly that as we optimize our materials for specific chemistries and for specific battery designs, there's a potential to increase that to as much as 20, maybe 25% increase in capacity. If you look at today, the market is looking at around $400 per kilowatt hour for energy storage with batteries. If we can enhance the capacity by 20% with our materials, you could extrapolate that into the cost of the kilowatt hour. So we feel that we offer a great deal of savings to those who are looking at battery development for energy storage.
Is it allowed to have some question from the audience? They
Certainly.
got the material.
Love to hear them.
Yeah. Yes.
Thank you. It's just a technical question about this sample. What does it mean, long way of the diamond and short way of diamond?
Ken?
So it's a way we kind of characterize the opening size. So the LWD is the long way of the diamond. So what that means, it's in thousandths of an inch. So if you have a number on there that's an 050 or a 100, it means 100 thousandths of an inch from node to node on the long way of the diamond. And the short way of the diamond is roughly a quarter to a half of whatever the long way of the diamond is. And we can change that geometry based on the angle of the die to be able to either increase that to make it more symmetrical or decrease that to make it less symmetrical or a smaller opening.
What might be good to explain is our machines create that diamond pore or open space in all of our materials. So if you held that up to the light, even though you can't quite see it, each one of those openings is a diamond. And that's what we're putting in there as dimensions.
Yeah. That's okay.
Is there another question directly from the audience right now? Can ask just right
In the
Did you
back?
see one? In the back? Where's the yes, I come around.
Well, I would like to ask about 3D printing and 4D printing, and what if there's any innovative solution to engage the battery industry and 4D printing.
I'm not quite clear on the question in regards to materials. Are you talking about the manufacture of a battery using 3D printing for the different materials?
Yeah, for different materials.
Yeah, I don't know if we have much room to play in that field because our materials are an expanded foil on which they then take the electrode we call it a slurry, where they mix it together with the binding material and the graphite. And then that's the paste that they spread on the foil. When you're developing a battery for the anode or cathode, typically if you spread that on a solid foil, you're just spreading it out. With our material, because we have more of a porous, rough surface, it has better adhesion for that material. So they may be able to get away with less binding material, which can help, and it gives it better stability. Other things we're finding is one of the other research institutes that are working with our materials have said they're getting better cycle life with our materials, probably because of the integrity of that porosity helps to stabilize it better. Those are some of the things that we offer as value add that we're learning about, but I don't know where they relate to 3D printing. I don't see us in that market or that field.
This was exhausting enough, yeah? Okay. Another question. We still have time for one other question. Okay.
I understood now what you're doing. I hope. Is this material, can you use it, for example, as a support layer or a backbone layer, for example, in the fuel cell for structures like GDL, or to support also the anode and cathode structures and materials?
Yes, you can, and that's some of the reasons why we passed around the thinner material. So, we can get down to either 15 or 20 micron. So it's a very thin layer, very smooth, flat layer that can support the gas diffusion layer or the membrane that's in the fuel cell. So if you were working at a higher temperature, or actually a higher pressure, and which may blow out the membrane, at least with this material, you can support that membrane so it doesn't fluctuate or move too far where you're actually destroying the membrane inside the fuel cell. So yes, it is a very good support material.
Well.
In addition, the pore size, someone was explaining to me the other day here with the fuel cells that with the pore size you can control the size of the bubbles that are moving back and forth. So you can maintain different flow features in the fuel cell with developing it for the pore size that's optimal for your system or your design.
If you have some further going on question, you're located at booth C38.
38, correct. Yeah, we're part of the Connecticut consortium down there. There's a number of different fuel cell companies that came over from the United States, from Connecticut, and we're kind of that fuel cell coalition that's in the northeast section of the United States. So we're with some really good groups and some good companies down there.
And you're directly in front of the technical forum?
Yeah, if you go to the technical forum, our stand is right there behind the technical forum. So very easy to find, and definitely invite anybody that wants to know more about the materials and grab some more samples. Please come down and grab some more samples at our booth.
Mr. Hart, did you see something in the technical forum that convinced you about what?
It's convinced me that the market is developing and evolving. As you'd mentioned, you've been around here for quite some time. I've been in the fuel cell and battery business for about 10 years, maybe almost 12 years now. And the growth and changes that I see are phenomenal, from when this started as designs and concepts to now seeing real products. And we're seeing the same thing on the battery side with lithium-ion batteries, the technology, we're now down to nanowires and getting much more capacity into the batteries and continually refining to improve and, create more energy storage and hopefully driving down the cost.
So that means you're on the right place here.
Yeah. We're in the right place at the right time, yes.
Yeah, I think as this technology develops, we're always trying to drive down costs. And that's one of the reasons why we've been instrumental in the fuel cell industry, is because the expansion process really lends itself to being a cost-effective solution to being able to supply an open area product. The expansion process, it's not like a perforating where you're just knocking holes into it and you're scrapping out 50% of the material. If you put a meter of material in, you're getting a meter and a half of material out. So expensive materials like the titaniums, or maybe you're using a niobium or a zirconium, it's much more cost effective to use the expansion process than it would be a perforating process or even a woven wire process.
And this is exactly that, what you can talk for hours at your booth, right?
Absolutely, absolutely.
Mr. Kenneth Burtt, Mr. John Hart, I thank you very much for giving an overview about your products. So, if you'd like to visit them on the booth, Mr. Kenneth Burtt and Mr. John Hart. Give us a short applause.
Thank you for
please.
your time this afternoon.
Thank you too. As next, here on stage, just in a second, in situ and ex situ chargeration methods for fuel cell by the owner of Bilvatec, Furkan Dunha.